Okay, so in today's recording, Craig, who has joined me today, is going to give me a tour of how the Taka deployments repository builds dynamically its CI configuration. Take it away, Craig.
Hi, Scarbeck. Craig didn't prepare this at all, so be prepared for a bumpy road with lots of ums and ahs. I'm just getting all my stuff ready. And I'll share my screen. All right, maybe I need to make this font size bigger if this is going to
I
go
would
on
highly
unfiltered.
recommend bumping the font
Yeah.
size since I plan on shoving this into YouTube.
Um, okay, so before just diving into the actual Jsonnet, uh, which I don't think will be very helpful in isolation, I should describe what Tanker deployments is and does. Tanker deployments is a monorepo that uses Grafana's newfangled-ish Tanker tool to deploy various things to Kubernetes. We've got a bunch of workloads we'd like to run, such as like Thanos or like Woodhouse SRE helper tool. And most of these have at least one environment. For example, we have a Thanos store in every Google project in which we run a GitLab environment. We have test environments for things, staging environments. Soon we'll want to move Prometheus in here, which is another kind of cluster local thing, like at least one per cluster. And the aims of this repo are to be able to share. Oh yeah, so for anyone who doesn't know, Tanker is JSONnet based. It's actually, and if anyone doesn't know what JSONnet is a simple one of these like configuration languages. It's a full-fledged programming language, but quite stripped back and oriented around serializing JSON documents. It can also serialize like YAML and INI, but it's essentially a programming language without a whole lot of standard libraries for things that you might expect, like interacting with files and networks and all that, and is instead just oriented around functional transforms of data structures
But hopefully
for
easier
output.
than, say, Bash, where
Oh
it's hard
yeah,
to do arrays and such.
yeah, absolutely. It is quite simple, but the documentation is sometimes like a little lacking. On the other hand, I'm sure we'll see that. Right. So what are our objectives? We want to have a bunch of things we deploy. So Tanker deployments is newish. We haven't got around to moving tons of stuff into it. It's only got 5 workloads. Like some of these things like syscuttle patch, evicted pod reaper, and Thanos, these are components that we want in every cluster, as with Jaeger, and then some things we have in fewer clusters, but whatever. We put them in one repo because why not? Because we don't want to reinvent the CI deployment wheel and use things like GitLab CI includes, which can be a bit like annoying to sync up between lots of different repositories. And we want the opportunity to frictionlessly share Jsonnet libraries between these various unrelated like or semi-related releases without having to coordinate like JSONnet bundler version bumping, things like that. It's just kind of easier. But that comes with a price tag, which is if you want a sort of minimal clean CI pipeline that doesn't run like hundreds of steps for your various projects, then you have to work at it a bit, like even with GitLab's like nice CI system. So we very quickly figured out that using GitLab CI's own YAML abstractions was maybe going to be, no offense to the verified team, maybe going to be like a bit more work than stepping back and building our own abstractions to serialize the GitLab CI YAML instead. And because this project is already JSONnet heavy, we made GitLab CI.jsonnet instead. And before diving into, can you see the terminal, by the way, on my other window? Have I been sharing the right thing this whole time?
Yeah, I see.
Yeah,
We
nice.
have GitLab CI JSON up.
Yeah, awesome. I was checking I shared the right screen, so I can't quite tell. Um, Rather than dive right into that, let's first look at how we want the pipeline to look. So going back to this environments directory, right? We've got pieces of software like Evicted Pod Reaper, Jaeger, Thanos, Woodhouse, and each one of these has the sort of pet name of one of our Kubernetes clusters. So gprod is Google production. At least I assume the G stands for Google rather than GitLab.
Indeed, it does.
Yeah, just checking that. Maybe it stood for GitLab the whole time, and I forgot about that. But yeah, we got gstage, gprod, pre, which is a kind of like infra test environment for anyone who doesn't know. Dev is the exception. Dev is actually just a relatively agnostic sort of Minikube K3D compatible release that's that contributors to this repo are meant to try to use for iterating on something local before pushing to a shared thing like pre or G stage. And each of these environment directories contains what's called a tanker environment, which is effectively a description of some like one or more Kubernetes resources to deploy to a namespace in a cluster. This video is not going to be about Tanker itself, although I would really encourage people to check it out because it's really awesome and I really like using it. It's instead going to be about how we coordinate CI for this. So ideally, when a developer pushes a branch, we want to produce TK diffs, which are essentially kubectl diffs for the environments they change, and ideally nothing else. When master is merged, we want to produce diffs again, and then possibly manually gate the apply step, the kubectl apply of those resources. We actually, at the moment, we do have that manual gating for prod environments. So gprod and our ops cluster, which is the kind of production, operational and observability control plane Kubernetes environment, where we run things like Thanos query. But we just auto deploy staging and pre and all the non-prod environments without any gating.
Because similar to how we do it pretty much everywhere almost at this point.
Exactly. I realized that this was already in the Helm repos, but we didn't have that in Tanker. We were clicking buttons in pre. So we didn't want to do that anymore. So we removed the gate.
Yeah.
There is some other nuance to Tanker called pruning, which is like apply but for deletion, which is these days inlined with apply. So we can think of this as we've got a bunch of directories structured like this, software named and environment names, and when they're diffed by a commit, we want to diff only those environments, and for master commits, we want to apply only those environments. So that produces pipelines that look like this. Let me try and find something. So if I grab this pipeline, oh, that's a bad example actually. We can maybe come back to that as a later example because this is another use case for dynamic pipelines. Here's a master pipeline. I'm looking for a non-master pipeline. So when I mentioned about changes, we'll come back to this, but often for the diff stages, very many jobs are run. All of the jobs are run because of a GitLab CI documented quirk in which new branches don't have change rules applied to them. They end up triggering true for like every changes rule. This is actually something I have an open issue for that the Verify team are considering fixing, I think, which is good. So I'm just looking for something that doesn't exhibit this bug. Pretty much everything does, unfortunately. Yeah. Well, we're not going to be able to see the effect of nice changes rules, but we can see, for example, a master pipeline here in which we have various kind of generic steps. We have one diff step per environment. In this case, it's running them all. You'll have to take my word for it. Sometimes when we get really lucky, we do, especially on master pipelines, do see only some of these running, but this is all of them in this case.
So just the ones that you're targeting. So like if I was only modifying the sysctl stuff, you'd only see the sysctl like diffs jobs and not the evicted pod reaper and Jaeger and such.
Absolutely. We'll get like more detailed exactly what triggers what when we dig into the file. And then because this is a master pipeline, we have the apply phase.
Yep.
We want manual gating for some environments like gprod and ops, but not all. We want jobs to run as independently as possible. So for example, we want the Jaeger G stage apply to run when the Jaeger G stage diff finishes without waiting for everything else in the diff stage using GitLab's directed acyclic graph feature needs keyword. And that's really all we need to see about our like main kind of pipeline. So let's dive into the code and see how we've accomplished that. So starting from the bottom, right, we call Jsonnet's manifest YAML doc function with a GitLab CI conf object. So this GitLab CI conf is some like JSONnet object that has all the various structures that make up a GitLab CI. It's got a stages section. You can look at how this gets translated, actually. That transforms into this.
Yep. Which looks familiar. I recognize that.
Absolutely. Unfortunately, Jsonnet manifest YAML doesn't include any options for like pretty printing, like removing quotes where it can, or white space, things like that,
Yeah.
indentation. So it's kind of a very verbose, like standard YAML. But yeah, we don't really look at the YAML very much.
Exactly.
Yeah, we even prepend this string at the top. Do not hand edit.
Yep.
This explanation here. We have a workflow section. This I might be able to remove this. This works around a bug in GitLab CI in which when a pipeline configuration reaches a certain complexity threshold, MR pipelines and commit pipelines start being kind of arbitrarily double triggered, and you can use the workflow rules to pin one or the other. But I think this might have actually been fixed recently, so I might try removing this. Then going back down, we've got some jobs, like a cert formatting, checking that the generated code's up to date, that kind of thing. That's not particularly interesting. These jobs are just fairly vanilla, whatever.
Yep.
Then we've got these interesting parts here. We've got these tanker jobs functions being called, passing in various things like Thanos, G-Stage, Jaeger Priest. Some of them even have extra params. So let's jump up and take a look at what this function does. Actually, I want to keep the YAML on the right, and so we can look at it later. Let's jump to Thanos G-Stage diff in the YAML first. Apologies for the constant jumping. So what do we want to do, right? We want to run some image that contains tanker. We want to, I'll come back up to rules. We want to run some script, like log into the Cuban environment, vendor stuff, blah, 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 run a diff, you get it. That's in a stage just for like nice decoration on the pipeline. It has some tags because we need to access our VPC, so we pin it to certain nodes from our ops server.
Yep.
It's got some variables, the utility of which might become apparent in a sec.
Well, I recognize some of those. Those would help you log into the appropriate cluster that you're targeting, probably.
Yeah, we can look at the kube control login script using some of these. So we grab the variable called environment, which here is G-Stage, and use that to reference a CI variable, which is a private key needed to authenticate with G-Cloud.
Yep.
The tanker env variable value here is a directory path, environments, Thanos, G-Stage, that we feed to tanker here to tell it what to do. I mean, there's more than one way to skin that cat. I mean, to be perfectly honest, if I was writing this today, I would just environments Thanos G-Stage and like not have it as an envar because we're generating this config anyway, but whatever.
Exactly. Yeah.
And then we've got some rules. This is the most complex bit of the config. All right, what is all this? This is more rules than we normally have in a CI step here at GitLab. Well, first of all, if you're familiar with the new rules changes syntax, as opposed to like the old, I think deprecated now potentially, the only accept syntax.
Yeah.
We want to only run this job when one of these things has changed, like at least one of these things has changed. So this is an or. Environment Thanos G-Stage star. So if we actually change this environment, and then we've got a bunch of like pessimistic constraints. We want to err on the side of running jobs. So if we change the vendored Jsonnet dependencies that Tanker uses, that we can't necessarily tell which environment it's really targeting. If we change the CI config, run every job. And if we change any of our shared like common libraries under lib, because we unfortunately don't have a mechanism for like reverse bubbling, like, oh, we changed this part of lib and that's used here, here, and here. We only need to run these jobs. That's way too complicated. We'd rather spend the money on running the jobs. So we err on the side of running jobs. So commits that change some core stuff will end up diffing everything. But then if you have a nice targeted commit that only changes one environment, it hopefully should trigger just that job. And finally, the changes is anded together with this if the variable tanker deployments run is set to 1. This is an artifact of our mirroring setup. We push commits to gitlab.com. But because uniquely, like unlike other customers of gitlab.com, us on the GitLab infra team are like operating crucial components of gitlab.com. So we tend to operate that from another GitLab server, a private one, ops.gitlab.net. Lots of people watching this video will know that. We push mirror to ops.gitlab.net, and on there, crucially, I'm going to try and not leak secrets, which I think is possible because I think I shouldn't leak them because there should be starred out. Yep, good. Here we've got, I'm not going to click reveal values to reveal them all. We've got tanker deployments run, and I'll tell you a secret, it's set to 1 right there. And we don't set this on.
I'm surprised that you don't use the there's a referenced CI variable that lets you know which instance you're on. I'm surprised you don't just leverage that as a mechanism instead
Using
of
the API URL, you mean?
I think that's right. Like there's like an instance URL that says, "Hey, I'm ops.gitlab.net" or "I'm gitlab.com." I'm
Yeah,
surprised you don't
it's
use that.
I think we do that in the Helm repos.
Yep.
That would also work just fine. I mean, realistically, we're very unlikely to change our server URLs
Yeah,
anytime soon.
it serves the same purpose,
Yeah, this felt somehow
just a
more
different way of doing
explicit.
it.
Like I'm enabling
Yeah.
tanker pipelines for this, but
Yeah.
no, that works too. And in practice, it doesn't matter very much. So this here will ensure that .com pipelines are never triggered. In any case, .com doesn't have the secrets necessary to log into the clusters.
Yep.
So if you're watching this on the internet, going to attack GitLab, you've got to attack the ops server, not the .com server. Yeah, that's the gist of it. So because of the complex rule stanza, because of the need to control, like, I know I replaced tanker end with this, but because of the need to kind of template a little bit of stuff, we very quickly realized that doing that with the abstractions provided in the GitLab CI YAML was maybe not going to be quite as nice as just simply serializing this. Yep. So tanker jobs is a, meaty-ish Jsonnet function that's starting at the bottom, looking at what it returns. It returns an object with these jobs. So software here would be like Thanos, cluster would be gstage, for example. Put the stage in, you put your, you put your script in, you assemble your relatively complex rules. The nice thing, and this is another reason actually, by the way, that pushed me towards GitLab CI.jsonnet instead of using like YAML anchors and YAML includes, because rules is an array, unlike the old only except syntax. There wasn't really a nice way to dry this out somewhat, and we would have had, I mean, there's about 1,000 lines in here, right? We would have had many hundreds of lines of repetition trying to duplicate the rules like this one and things like that. So it's a bit drier here. You've got, rule enabled deployments plus env changed, which, what's the definition of env changed? Yeah, right here, you've got your, because we call tanker jobs for everything. So we've got different envders for each. Then we add the kind of pessimistic part. Yeah, we could even, here you can see we're using a Jsonnet extension. So we're mixing in to this base job. We this is maybe a bit overboard, but like Jsonnet makes it really easy. So rather than even duplicate things like image tags and variables, we just extracted that out into an object and reference it from both the diff and the apply job down here.
Yeah.
And that's really about it, because now we've actually covered this whole file. Like it's a meaty-ish. It's like 305 lines of Jsonnet. There are no imports though, so there's all the context is here. And it's so far generated about 1,000 lines of CI YAML, and we are nowhere near done with this repo. We're going to bring in a lot more stuff. So we're going to balloon this config out potentially, maybe hit some API maximum.
So we, as people who are generating a CI configuration, should not touch the actual YAML file that gets generated. What would be the appropriate command? Maybe you have something inside this tanker repo specifically, but what is the command that generates that file?
I'll show you. We'll look in the make file. So make generate CI config runs jsonnet --string.gitlab ci.jsonnet redirecting to GitLab CI YAML.
Okay.
And we have a CI step that checks that the generated code matches the final result. Now, of course, you're contributing to the CI config, you can just remove this job, right? But it should work most of the time. The --string. So Jsonnet is pretty simple. The only reason for this is to say that JSON usually generates JSON. So if you want to generate anything else, like use functions like manifest YAML doc to return a string, you just tell it, don't expect JSON. I'm just going to give you a string as output. It's just some boilerplate you have to put on there.
Okay. Okay, so from the perspective of someone who might be newer to Jsonnet, such as me, where would you go for the best documentation or learning tutorials that may be available out there?
Two
You mentioned the
places.
Jsonnet documentation is maybe not the greatest. So if we have
It's
other
improved a
places
bit,
that we
but
could check out.
yeah.
Okay.
I would start with the Jsonnet tutorial on jsonnet.org. This kind of has everything in it. It's done by example, which is nice. There's really not a huge amount to Jsonnet. It's it's a smallish programming language similar to Q or DAL, if you've seen those. They're called kind of configuration languages these days. A niche for a niche for people who intentionally perhaps don't want all of the bells and whistles of a general purpose programming language like Ruby, Go, Python.
Exactly.
Good for this kind of thing. So I'd read the tutorials. It's not super long. And then you've got the Jsonnet standard library. And then beyond that, like once you practice with that a bit and looked at our existing Jsonnet, which we use Jsonnet in a few places in GitLab Infra. We use it in Tanker deployments. We use it quite liberally in the runbooks repository, which is actually a mono repo for way more than just runbooks. We use it as the basis of our metrics catalog, which generates Prometheus configuration and dashboards for our various services. Beyond that, it's really just the context you're running Jsonnet in. Like if you're running Tanker, which this video has like broadly not been about, like you've seen me just calling out to Jsonnet here. If you're using Tanker, then technically you're not like shelling out to a Jsonnet executable. Your Jsonnet is consumed by an in process Jsonnet interpreter inside the Tanker executable, but that's usually a fairly minimal consideration.
Gotcha. Well, excellent. I don't have any further questions. Do you have anything else that you want to quickly gloss over?
No, I think that's about it from my part. I have a meeting to run off to in 2 minutes.
Perfect.
So I do have to go.
Well, thank you much, man. I appreciate the overview. And
No
I'll send
worries.
this up to YouTube shortly. So I
Yeah,
greatly
I
appreciate
look
it, man.
forward to recoiling at the sound of my own voice.
All right, man. Have a good one.
You too.
Later, man.
Bye-bye.